Okay, ma, what we discussed in the previous session? Can anyone please respond what we discussed in the previous session? Please respond. Nalini or Rishita, can anyone please respond, ma? Seishu, Sarath, yes, what we discussed, ma? We have seen what is a context-free grammar, right? We have seen what is a grammar, and then how can we construct the grammar if they give you the language, and how can we construct the language if they give the grammar. These things we have seen, is it not? Next we have seen recursive grammar and ambiguity grammar. Derivation trees we have seen. So next concept is first I'll let you know the what is Chomsky hierarchy, then we'll move on to the parse trees. Okay, today's session we'll see what is Chomsky hierarchy, and then we'll move on to the after Chomsky hierarchy we'll move on to the parse trees. Okay. Starting lo nenu meeku cheppana what is a Chomsky hierarchy ani eppudaina?
No, ma'am.
No, right? Okay. We'll see what is Chomsky hierarchy first. See, ma, Chomsky hierarchy means first there is a regular grammar. First there is a regular grammar. Next there is a context-free grammar. Next there is a context-sensitive grammar. Next is recursive enumerable grammar. This thing we may call it as Chomsky hierarchy. దీన్ని మనం ఏమని చెప్పవచ్చు? Chomsky hierarchy. Can anyone tell me What can you call this regular language? Regular language grammar is nothing but the regular grammar, and the machine accepted by the regular language is the finite automata. Context free grammar is nothing but context free. Okay, I have written regular grammar, so it is regular language. The language which is generated by context free grammar is nothing but the context free language, and the machine accepted by the context free language is nothing but PDA, push down automata. Next, context sensitive grammar. The language which is accepted by the context sensitive grammar is known as the context sensitive language, and the machine is LBA, linear bounded automata. Next, recursive enumerable grammar. The language which is generated by recursive enumerable grammar is recursive enumerable language, and the machine is Turing machine. Machine accepted by the regular recursive enumerable grammar is Turing machine. So we have completed in the first two modules, we discussed this regular grammar, regular language, and finite automata and its classification. Is it not? Antena manam chusindi.
Yes, ma'am.
Yes, ma'am.
Now we are moving to CFGs. Third module is completely on CFGs. So the grammar, the language which is generated by context free grammar is known as the, what is the language? Context context free language. The machine which accepts the context free language is known as the
Push down automata.
push down automata. So in this module, we are going to discuss this context free language and push down automata. Okay, this regular enumerable recursive enumerable grammar, you may call it as this is type 0 grammar, and context sensitive grammar is type 1. Context free grammar is type 2. Regular grammar is type 3. Okay, explain about type 0 grammar, then you have to write recursive enumerable grammar. If they give you the question like explain about type 2 grammar, then you have to give the explanation about context free grammar. They may ask explain about the machine which accepts type 3 grammar. Type 3 grammar means which is regular grammar. Regular grammar means the machine accepted by regular grammar is finite automata. So you have to explain the finite automata. Am I clear with this Chomsky hierarchy?
Ma'am, can you explain can you give the full form of LBA, ma'am?
Linear bounded automata. Okay. Anyway, we have completed regular language finite automata. In this module, our concentration is only on CFL. After this next module, anyway, we'll learn that CSL. Then we'll get familiarized about the automata. Okay, ma'am. This is simply the hierarchy which is available in the third module. Okay, in that type 3 grammar or regular grammar we have seen. In this module, we are going to learn CFG. In the coming modules, we'll learn CSG and recursive enumerable grammar. Am I clear with this hierarchy?
Yes, ma'am.
So, if the language accepted by Turing machine, which means the final one, if the language accepted by Turing machine, okay, is the same language can be accepted by the regular grammar? నేను అడిగిన క్వశ్చన్ మీకు అర్థమైందా? ఒక లాంగ్వేజ్ తీసుకుంటే ఆ లాంగ్వేజ్ ట్యూరింగ్ మెషిన్ యాక్సెప్ట్ చేస్తుంది. సేమ్ లాంగ్వేజ్ విల్ ద రెగ్యులర్ గ్రామర్ యాక్సెప్ట్స్. రెగ్యులర్ గ్రామర్ యాక్సెప్ట్ చేస్తుందా ఆ లాంగ్వేజ్ ని? Did you get my question? No. Why? Because if the language which is a regular language, is it recursive enumerable language? For example, a power n or a star, it is regular language. I think all of you are familiar with this because we can able to construct the finite automata for this regular expression a star. So it is a regular language. Will it be a recursive enumerable language? Regular languages and recursive enumerable languages avutaya avava? A diagram ni batti meer cheppagalarramma?
Yes, ma'am.
Yes, because the regular grammar is the smallest one. E biggest circle is smallest one unda leda? So the language which is accepted by the finite automata is accepted by all the remaining machines like PDA or LBA or Turing machine. So can I write like this? regular language subset, CFL subset, or maybe it may be equal, or CSL subset or equals to recursive enumerable language. Can I write like this? Because regular language is in the part of the CFG only. CFG is in the part of CSG only. CSG is in the part of a regular enumerable language only. Can I write like this?
Yes, ma'am.
Okay, this is simply nothing but the Chomsky hierarchy. Now I'm moving towards the first concept of this third module is nothing but the CFL. మనకి స్టార్ట్ అవడమే కాంటెక్స్ట్ ఫ్రీ లాంగ్వేజ్ అని స్టార్ట్ అయింది. మరి నేను ముందంతా మీకు ఇంకా వేరేవి నేర్పించాను. ఏం నేర్పించాను? వాట్ ఈస్ ఏ గ్రామర్, వాట్ ఈస్ ఏ ప్రొడక్షన్, హౌ కెన్ యూ కన్స్ట్రక్ట్ ద ప్రొడక్షన్స్ ఇఫ్ దే గివ్ యూ ద లాంగ్వేజ్, హౌ కెన్ యూ కన్స్ట్రక్ట్ ద లాంగ్వేజ్ ఇఫ్ దే గివ్ యూ ద ప్రొడక్షన్. దీస్ థింగ్స్ నేను మీకు చెప్పాను. Right? I taught all these things, but the first concept in your third module is CFL only. Why I taught all those topics, you'll get to know. First, in this module, our complete interest is only CFL. CFL ante ekkudundi, which is after regular language. Context free language is after the regular language. Okay. So what is this CFL? CFL is a context free language. Okay, CFL is a context free language. The grammar which is generated by the context free language is the context free grammar, which is CFG. CFG must be in the form of A to alpha. If CFG is in the form of A to alpha, then A belongs to V and alpha belongs to V plus T star. Okay, A tends to alpha, A belongs to variables, alpha belongs to variable plus terminal whole star. I think now you will understand why I taught what is a grammar, what is a variable, what is a terminal, what is a production. See, now you are familiar with what is V. If I did not teach those concepts, you did not understand what is V, what is this T and all, right? So that's why I taught those concepts. A belongs to V. A belongs to V means, what is a V here? I'm expecting
Variable, ma'am.
Variable. Variable means, is it in the capital letter or in the small letter? Variables ante caps lo untaya, small lo untaya? దీన్ని బట్టే మీరు చెప్పేసి ఇక్కడ నేను capital letter రాసానా, small letter రాసానా?
Caps.
Capital, ma'am.
So variables are always in the capital letters. Next, alpha belongs to V plus T whole star. What does it mean? What is plus here? Plus ante kuda meeku ento telusu. What is plus operation? It is union operation. A or B. A or B means you may take either a variable or you may take either a terminal whole star. Sometimes you may have epsilon also. This is nothing but the context free grammar. Context free grammar means which is in the form of A to alpha, where A belongs to variable and alpha belongs to variable plus terminal whole star. Am I clear with this?
Yes, ma'am.
Okay, I'll give you one example. You tell me whether it is CFG or not. Okay, so simply I'm writing S tends to AB. Simply I'm writing S tends to AB. A belongs to AA or epsilon. B belongs to some simply B. Is it CFG or not? Is it CFG or not? Please respond. Is it CFG or not? What is the rule I told you? A to alpha. A belongs to variable. Alpha belongs to either it is a variable or a terminal or both combination of variables and terminals whole star. So we'll check each and every predictions. First, how many predictions you are having here? Total 3 predictions. First, we'll go through the first prediction. S tends to AB. First, S belongs to variable. Is it not? Capital letter kada nenu rasana akkada. Does it belong to variable or not?
Yes, ma'am.
Now AB, here I have written AB. Now alpha belongs to variable or terminal. It doesn't mean that whole star. Whole star means you may have any number of variables or you may have any number of terminals or you may have combination of variables and terminals, or you may have epsilon. So it is having combination of variables only. Is it following the given context-free grammar or context-free language rule? Is it following or not?
Yes, ma'am.
Yes. So first production is absolutely belongs to context-free grammar. Next, A2, AA or epsilon. Variable plus, first we'll check with this. A belongs to variable S. Yes or no? A belongs to variable. Is it true or false?
Yes, ma'am. True, ma'am.
Yes. Next, it is a combination of variable and terminal or epsilon. Is it following the rule or not?
Yes, ma'am.
Yes, ma'am.
Yes. B to B. B belongs to variable. Is it true or false?
Yes, ma'am.
True, ma'am.
B is terminal. Can I take like this? So here I have covered everything. Two variable combination వస్తే ఎలా ఉంటది, variable terminal combination వస్తే ఎలా ఉంటది, only terminal వస్తే ఎలా ఉంటది, or else if you have epsilon. Am I clear with this? Am I clear with this, ma?
Ma'am,
Hmm.
for B belongs to B, small b we don't have to consider, like we don't have to search for a variable, ma'am. Directly we can assume it is a terminal.
Yes, if it is a small letter, it is directly a terminal.
Okay, ma'am.
Okay, this is nothing but the context-free grammar. I think I'm clear with this context-free grammar, is it not? Am I clear with this, is it not?
Yes, ma'am.
Next, we'll move on to derivation tree, or you may call this as derivation tree or parse tree. దీన్ని మనం parse tree అని కూడా పిలవచ్చు. ఓకే, నేను మీకు లెఫ్ట్ మోస్ట్ డెరివేషన్, రైట్ మోస్ట్ డెరివేషన్ చెప్పానా, చెప్పలేదా? ఓకే, ఎనీవే చెప్పినా చెప్పకపోయినా చెప్తున్నాను. లిజన్. ఫస్ట్ విల్ గో టు డెరివేషన్ ట్రీస్. ఈరోజు మీకు ఎగ్జామ్ ఉందమ్మా, అయిపోయింది.
Yes, ma'am.
Yes,
We have an exam.
Okay, derivation tree. What is a derivation tree? Derivation tree means if you have a production, okay, from that production you have to derive a string by constructing a tree. You have to derive a string by constructing a tree. We'll consider one example and then I'll let you know what is this. S tends to 0, AB1. S tends to 0, AB1. Now what is A? What is A? What is B? A tends to 0, B tends to 1. A tends to 0, B tends to 1. What is a derivation tree means? From this given productions, we have to generate a string by constructing a tree. We have to generate a string by constructing a tree. What does it mean? First, S I have considered. How many symbols we are having here? 0, A, B, 1. A is generating 0, B is generating 1. All together we'll call this as 0, 0, 1, 1. Am I clear with this? Am I clear with this? Have we got?
Yes, ma'am. Clear.
This is nothing but the derivation tree. Derivation tree means generating the string from the given productions by constructing a tree. దీన్నే మనం డెరివేషన్ ట్రీ అన్నది, దీన్నే మనం ఏమని చెప్పి పిలవచ్చు అంటే పార్స్ ట్రీ. డెరివేషన్ ట్రీ ఆర్ పార్స్ ట్రీ. Derivation tree or parse tree. We'll see one more example. S2AAS, S2 AAS or A or B S2AAS or A or SS, SBA or BA. SBA or BA. A tends to A or SS. Assume this is the given prediction. So what I'm doing, S tends to, first I'm generating the first prediction. First I'm considering the first prediction. In place of A, I may consider SBA. In place of S, earlier I have considered first prediction, now I'm considering A. Now in place of A, capital A, I may consider directly BA because earlier I have considered first prediction. Now in place of S, I may generate A. What is the string it is generating? AA, BB, AA. So this is nothing but the parse tree. Is this the only string possible or can we generate any other string? What, Nalini?
Ma'am, we can go for the other one also, ma'am.
Yes, we
S
can
tends
go
to
for the
SS.
Other one too. Other one too means S tends to. Suppose if I consider SS. Again, this S tends to. I may consider directly AA. It will give you AA. Not only the string, another is also possible. If I consider in place of S, if I consider AA is like this. So from the given prediction, there is no mandatory condition that it is generating only one string. Earlier, of course, it is generating only one string. There is no other possibility. But it doesn't mean that always it generates only a single string. It doesn't mean that like that. Okay. So the given prediction may generate n number of strings that depends on the given prediction. Am I clear with this? What is a parse tree? I think you got the clarity, right? If they ask you to construct the given string, if they give you the string, you have to follow that. Otherwise, whatever the string you can able to generate, you can generate. That is nothing but a parse tree. I think I'm clear with this parse tree. Say yes or no. Say yes or no.
Yes, ma'am.
Okay, I'm moving forward. What is the leftmost derivation and what is the rightmost derivation? We'll discuss. Leftmost derivation. Leftmost derivation means here always will derive the leftmost symbol. How can we use this? We'll see now. S tends to ASA or B. S tends to ASA or B. A tends to AB or A. AB or A. Okay, ma? This is the given thing. How can we solve this? See, here I'm not going to construct the parse tree. Here I'm going to use what is the leftmost derivation. అంటే నేను ఈల్డింగ్ అంటే ఏంటో నేను మీకు చెప్తాను, మీకు అర్థమవుతుంది చూడండి. ASA. Okay. So here how many variables you are having on your right hand side?
2, ma'am.
2. But here first I'm yielding this one, leftmost one, first I'm executing. Leftmost one means in place of S, can I use B? In place of S, can I use B? Say yes or no.
Yes, ma'am.
Next, this is nothing but the A. ఇప్పుడు next E symbol ni నేను evaluate చేస్తున్నా. In place of A, can I take A directly? Right? This is nothing but the leftmost derivation. Always I'm preferring to evaluate the left one first. That is nothing but the leftmost derivation. Okay. This is nothing but yield. ఏమని చెప్పి పిలుస్తామంటే yielding అంటాం. S yields B. A yields B. So this entire part we may call it as leftmost derivation. Then what is rightmost derivation? For example, I'll let you know. ASA. First, I'm not evaluating the leftmost one. I'm evaluating the rightmost one. In place of B, can I use A? Sorry, in place of A, can I use A here? Yes. Next, after this, what is the next rightmost? S is the next rightmost. In place of S, I have used B. This is leftmost derivation. This is rightmost derivation. I think I'm clear with this, right? Am I clear with this?
Ma'am, here instead of using small a, can we use capital AB also?
Yes, we can use.
Okay, ma'am.
That
Thank
also
you.
I'll explain here itself. I'm erasing this. S tends to A, S, A or B. I'm going for leftmost derivation. So in this part of S, I'm again substituting S, S, A or B. Okay, in this S part, I have substituted this A, S, A. Any confusion here? Any confusion, ma'am?
No, ma'am.
No, right? So AA in place of S, now I'm substituting B. I'm writing AA as it is. Okay, sorry. I did not. Now, next leftmost symbol is A. Though this A is present before this, but I'm evaluating the leftmost part only because this is leftmost derivation, no? So AAB in place of A, I may substitute again AB, capital A. Now again AAB in this part, I may substitute A. This is B directly. Next AAB, AB in place of A, I'm substituting B. This is also possible, right? Always I'm preferring to evaluate the leftmost one first. I think I'm clear with this leftmost derivation. Is it not? Am I clear with
Yes,
this?
ma'am.
Okay, next I'm moving forward. Next, after leftmost derivation, we are having rightmost derivation. That also I have explained. Next, ambiguity. What is ambiguity? I think I have explained you what is ambiguity. Ambiguity in CFG. Ambiguity in CFG. Ambiguity in CFG means, what is ambiguity? I think నేను మీకు డాలో మీకు డాక్ నేనే కదా వచ్చింది మీకు నేను డాలో కూడా ఎక్స్ప్లెయిన్ చేస్తా ambiguity. First when I taught what is an algorithm properties లో definiteness means every instruction must be clear and unambiguous అనే పాయింట్ దగ్గర what is ambiguity అనేది నేను మీకు ఎక్స్ప్లెయిన్ చేశాను. What is ambiguity? Ambiguity means there are two solutions, more than one solution, not only two, there are more than one solution, which means the compiler does not able to select which one I have to choose, because we are humans, we can think and okay, random ga manam okataina pick chesukogalam, but the computer does not able to think on itself. So your instruction should not be ambiguous అని చెప్పి నేను మీకు అక్కడ చెప్పాను. What is ambiguity means, there is more than one solution. That is nothing but the ambiguity. Okay, I'll give you the example, then you'll understand what is this ambiguity. Sorry. S tends to AS or SA or A. Okay, now I'm asking you to generate the string AA. I'm asking you to generate the string AA. First, I'm constructing the AS. In this part, which is rightmost derivation, right hand side, you are having the capital letter. Yes. AA generate అయిందా అవలేదమ్మా మనకి ఇక్కడ? అయిందా? Next thing is S tends to SA. Here A. Here also A. Is both the derivations same? Is both the derivations same? Say yes or no. Derivation, both are generating the same string, but both the derivations are not same. Is it not? Are you following, ma? This is rightmost derivation if you assume, this is leftmost derivation if you assume. But both are generating the same string, but the derivations are different. But the parse trees are different. Okay, this is known as ambiguous grammar. This is known as ambiguous grammar. Same string you can generate with two different parse trees. Same string you can generate with two different parse trees. So this is known as the ambiguous grammar. This concept is very, very important. They'll give you one string as well as the prediction and ask you to check whether it is ambiguous or not. I think I'm clear with this ambiguous. I'll give you one question. S tends to AB. S tends to AB or AB. S tends to AB or AB. A tends to A or AA. A tends to A or AA. B tends to B. Okay. Now you check whether it is ambiguous grammar or not for the given string AAB. AAB ki ambiguous grammar kaada na cheppandi. I'll give you 2 minutes time.
Done, ma'am.
Is it ambiguous or not?
Yes, ma'am.
Ambiguous. We'll check now. First, S tends to, I'm considering AB. What I need A. If I take A directly, I'll never get AAB now. So I'm considering this A as AA. Based on the string, we have to derive. So in this A place, can I take A?
Yes, ma'am.
So always I have evaluated the leftmost part. Next, B part I'm evaluating as B. So what is the string I got here? AAB. Is there any other possibility? Yes, S tends to AB. I have taken one more prediction is there. That is nothing but AAB. Now I'm evaluating rightmost derivation, rightmost to symbol, that is B. B tends to B. Now it is generating AAB. Both are generating the same string AAB. So can I call this as ambiguous?
Yes, ma'am.
Okay, we'll solve 2 more problems because this is very important concept. Please note down. E tends to E plus E. E tends to E plus E or E star E or A or B. Okay. Now you have to generate the string A plus A star B. Will you able to check whether it is ambiguous or not? Will you do it, ma?
Yes, ma'am.
Okay. Please complete it. Done, ma? Say yes or no? Sheshu? Seshu or
Yes,
Nandini?
ma'am.
Chesaramma?
Ma'am, is it
Is it
non-ambiguous?
unambiguous? You are thinking. We'll check. We'll check. Now, first, I'm taking E tends to E plus E. Okay. In this place, E plus E, can I take it like A?
E tends to A. Yes, ma'am.
Yes. So, first I'm deriving leftmost one. Next, I'm taking E
E
star.
star E.
In this place, I can take A. In this place, I can take B. A plus A star B, I got. Now I'll check with another one. Now I'm taking the next part. E star E. Earlier I have derived this. Now in place of this, I'm taking E plus E. Okay, next in this E plus E, first I'm taking it like A. Next also I'm taking A. Here can I take B? So A plus A star B. Is both the derivation same?
Ma'am, can we take at the time these two A's?
Okay, ma. If you want, you can take it like E. Anyway, it will get you write like this. Okay, ma. ఇక్కడ కూడా కావాలంటే దీని నుంచి ఇదేనా నీ డౌట్స్ ఇష్యూ
Yes, ma'am.
ఇలా డ్రా చేసుకోండి. ఒక్కొక్క సింబలే మనం డిరైవ్ చేయాలి. Am I clear, Nalini? Is it ambiguous or unambiguous?
Ma'am, can't we take E tends to A and E tends to B to another two more derivations, ma'am? It will become unambiguous.
See, ma, more than one unte అది ambiguous, నాలుగు ఉంటే అది unambiguous అని కాదు. If you can able to construct more than one, if it is 2, if it is 3, if it is 4, any construct చేసినది ఇంకా ambiguous అని. More than one exist అయింది అంటే.
Okay, ma'am.
Nalini?
Yes, ma'am.
I think now you understood, right?
Yes, ma'am.
Okay. One more example, if possible, we'll see. Okay. No, nothing, ma. Nothing is there. I think I'm clear with this. What is a derivation tree or parse tree? What is a ambiguous grammar? What is a context-free grammar? How it looks like? I think I'm clear with all this. Suppose A tends to A. Is it a context-free grammar?
No,
Yes, ma'am.
No, Seshu, because context-free grammar means always A tends to alpha ante A belongs to variable and alpha belongs to variable plus terminal whole star. Here first condition, A belongs to a variable. Small a variable or terminal?
Terminator.
Terminal. So it is not satisfying. So it is not a context-free grammar. We can see Q's lo ila adugutaru. Idi chesi check whether it is options ఇస్తారు కాంటెస్ట్ ఫ్రీనా రెగ్యులరా లేదంటే ఇంకొకటా అని చెప్పి అడుగుతారు. అప్పుడు యూ హ్యావ్ టు చూస్ ద ఆన్సర్. I think I'm clear with this CFG and parse tree and ambiguity or ambiguous grammar. I think I'm clear with all these three concepts, right? In the next session, we'll discuss about how can we minimize this grammar. I think I'm clear with this. If you are clear with this, we'll move on to the next topic in the next session. Clear, ma? Please respond. Please respond. Am I clear with this?
Yes, ma'am.
Okay. In the next session, we'll move on to the next concept. If you have any doubt, please raise your voice.
Ma'am.
Yes, ma. Nalini, cheppamma.
Ma'am, can you discuss the mid paper?
I think I did not discuss with you. I think I have completed with CS 12 people. Tarvata na manaki inka class raleda.
No, ma'am.
Okay. Shall I discuss tomorrow because today's the time out, no? Shall we discuss tomorrow?
Okay, ma'am.
మీరు ఫస్ట్ అడగాల్సిందమ్మా, నేను చేశాను అనుకున్నాను. యాక్చువల్గా CS 12తో చేశాను నేను. విల్ డిస్కస్ ఇన్ ది నెక్స్ట్ సెషన్. ఓకే, నో ఇష్యూస్. And I did not complete the evaluation too. By this weekend, I'll complete and I'll give you the marks. Okay. Tomorrow we'll discuss. Me first అడుగుంటే ఫస్ట్ డిస్కస్ చేసి మనం ఇక్కడికి వచ్చేవాళ్ళం. ఇప్పుడు టైం అయిపోయింది కదా, నెక్స్ట్ సెషన్ లో పక్కా డిస్కస్ చేద్దాం. గుర్తు చేయండి, ఫస్ట్ స్టార్టింగే గుర్తు చేసేయండి. డిస్కస్ చేసి మినిమైజేషన్ కి వెళ్దాం. Is it okay, Nalini? Okay, then if you have any doubt, please raise your voice. Otherwise, you people may leave the session.